After a 5:30 start and a reasonable drive from Canterbury all the way up to the NEC, the Sustainable Engineering Alliance team has arrived at Advanced Materials. Now, there is not a product on the planet that doesn't have material choice at the heart of its design, which is why we're here. And for leading edge products, for cutting edge products, for bleeding edge products, the only answer is advanced materials that allow them to innovate and move their products forward. So we are here at the Advanced Materials Show. But better than that, this is a 4-in-1 event. So in addition to advanced materials, we've also got, as you can see there, the Advanced Ceramics Show. And then we'll be going into the additional halls where we've got the Vehicle Electrification Show and also battery cells and systems. So this is day one of a 2-day event. And what we're going to be doing is one of our video marathons where we're going to be charging around all 4 of these, looking for exhibition stands that are highlighting sustainability, circular economy, recyclability, etc. We're going to jump on those stands, we're going to do lightning interviews, we're going to look at the products and technologies, get hands-on, dig down as deep as we can, and then bring those together as a single video review of the show, which will be going onto LinkedIn. And then we're going to chop it up into YouTube Shorts so that we can highlight the individual innovations stand by stand. So thank you very much, and off we go. We are on the Festo stand, and I am with Connie, and we're looking at some automation here, which is a process that is involved in the manufacture of battery cells. Connie's going to take us through the detail of this. We understand it's degassing. It's a Festo automation system here. Company I know well. I used to design machinery using Festo automation back in the day. So I'm going to hand over for a quick tour of this process. So, Connie, over to you.
Hi guys. So for those who don't know Festo, obviously we're an industrial automation company specializing in both pneumatics and electric automation. Also with a range of process automation, and basically what we're focusing on here today is, like you mentioned, battery degassing process coupled with a pick-and-place system in a battery manufacturing cell system. What I'd like to highlight of all these components is all these components are Festo components with a range of 40,000 products plus in our range. A lot of them focus not just on quality and energy efficiency, but sustainability as well. We have a philosophy within our product range that we use nature as inspiration. Hence for the gripper in this instance.
Okay.
So this entire process is fully electrically driven, making it very energy efficient and sustainable long term.
Yep.
But what we've done is we've taken it a step further for the battery industry, and we've launched a range of products that we refer to as F1A. And what that means is it's copper free, so it's suitable for the battery manufacturing industry.
Okay.
And we are continuously expanding our R&D in that industry as well.
Yep.
So be on the lookout for more innovation from Festo long term. This is just a very simple example of what we're capable of, but what we'd like to do is we'd like to partner with our company or with our clients around the globe, and not just offer them these high-tech or very sustainable solutions, but we actually partner with them in terms of product development as well.
Okay.
So if they have a specific requirement for any specific topic or specific applications, we will walk the road with them and take products or their feedback into regard and develop specific products for them.
Okay.
This is just one small aspect of what Festo does and what we see as the future of automation, being electric.
Brilliant. And the degassing process itself, can you just talk us through a bit of the detail?
For sure.
What does that actually involve, and why do you need to do that?
So a degassing process is very simple, and might come forth as very simple as well, but it's quite a crucial aspect. So when these battery cells go into a storage system as such, they have a tendency to swell up a bit.
Yes.
So due to the gases developing within itself.
Yep.
So what this does is, before a battery cell gets manufactured or stuck together, it has to be degassed for them to be as closely close together as possible to make sure it doesn't swell.
Right.
So before it goes from storage into being assembled, or like we say, modular and packed, it has to be degassed.
Right.
So all it does is it applies pressure from both sides at a specific force, and that slowly degasses the unit before it can go into the next step of the process.
Right, gotcha.
So that is what they refer to as degassing.
Yeah, okay, interesting. Looking at the actual machine itself, the end effector there that you mentioned, that looks like that's obviously specific to this application, and that's like a flexible tool, is it?
Yes.
So that it can grip it softly, okay. And that's the sort of thing that you develop in partnership with your customers.
The gripper in this case is what we refer to as an adaptive gripper. So it has the ability, like you can see, to flex in accordance to what the product is, the profile of the product.
Yep.
What's beneficial about this product is it can grip around round objects where a lot of other grippers can't.
Okay.
And in instances where you might have the pickup point might be different by a few millimeters to a centimeter or such. This will work around that. But this wasn't developed specifically for this application. This was developed as a general product in our product range. But like I mentioned, where the inspiration from this comes from is from nature.
From nature,
So what this specific inspiration was a chameleon's hand. So if you look at a chameleon's paw, it looks like that. So we've got a lot of products, and specifically that we develop with inspiration from nature.
Right, okay.
The counterpart to the chameleon, another chameleon product that we have, we don't have it here today, is what we refer to as an adaptive gripper as well. What that mimics is a chameleon's tongue. So it vacuums it. It's similar to that principle of a chameleon's tongue. So we have a philosophy of, even if you look at the Festo website, inspired by nature.
I have arrived at the IMI stand at the exhibition, and what we're looking at here, we've just asked a few questions about what's on display, and what we're looking at here are components specifically designed for battery manufacturing applications, in particular dry environments and also clean room environments. So I'm going to ask Sinelli for some detailed information on the types of products and innovations that we have here. So over to you, Sinelli.
Thank you, John. So we've got a number of different pneumatic products here on display today. So as you mentioned, we developed a number of pneumatics, so actuators, air preparation, flow sensors, a lot of products that have condition monitoring sort of built in as well, so IO-Link capable, particularly for use in sort of clean room and dry room environments. So clean room, particularly down to ISO 5, ISO 6, ideally suited. We're generally in the battery industry, and dry room, generally the kind of humidities you find at around minus 40 C. So we've got a couple of displays here, demos here, if you'd like to see. So I'm just going to run that control. And so that is one of our isoline F1 cylinders, so a feedback cylinder where it's got a potentiometer integrated. So if you are controlling the stroke, you can get a feedback back into your PLC that will tell you where the actuators reach. So you kind of have a closed loop control system. And you see here is one of our M80 flow sensors. So it'll give you pressure, temperature, and air consumption. So if you're looking to optimize your system, trying to reduce the amount of air your system's using, this will be a great way to try and know where your air consumption is currently at, identify leaks in the system. And over here, we've got one of our IEPS pressure sensors. This is a air preparation system with an integrated digital gauge. So you can preset your pressures, and as the pressure drops below or above the preset levels, the display will turn red or stay green if it's within the preset levels. So you kind of have that visual management, your control, you're able to kind of see if your process is within controls and stuff. So there's a lot of integrated monitoring, and they're particularly some of these products have already been tested at the Fraunhofer Institute for suitability in battery applications.
Yeah, that's brilliant. Thank you very much. I've bought lots of air prep stuff over the years for automation system I've worked on. I never had the luxury of having built-in digital diagnostics, or communications.
Yes, definitely.
Yeah, this is a world ahead of what I used to do. But so that's all about you kind of almost digitally twinning the system in the control network, I guess, so you can see what's happening in real time.
Yeah, so you're getting feedback from your system, so you're able to sort of see if your system's operating within its its optimum levels, where it's out of control. And especially if you're trying to look at the air consumption, you're trying to reduce how much air you're using, help you identify leaks, that's kind of where it all comes in. So you're kind of getting that closed loop control back with the feedback back to your system. So that's really the primary benefit with having the condition monitoring and the Industry 4.0 sort of allow your process to reach Industry 4.0.
Yeah, that's fantastic. I think from a sustainability point of view, obviously pneumatic systems they operate like almost like orchestras in factories, controlling so many functions, so many motions. They consume energy, obviously, so to get to that Industry 4.0, to reduce carbon footprint, etc., then the efficiency of these are super important. And I look forward to the day where all pneumatic systems have digital feedback in them so that the systems are being optimized. And this is a great example of this here. And now we're switching over to Jörg, who's going to take us through some of the sort of systems and processes on the back wall here. So over to you.
Hi. Hello. So as you see here, on one side you switch with Sinelli on the digital footprint and the IO-Link connections we have meanwhile, but we have also special approaches in battery manufacturing, which means in all those processes there are free commodities not allowed: copper, nickel, and zinc. The production is also an approach of a clean room, which is mostly on an ISO clean class between ISO 7 and ISO 9, and a dry room. And that makes products really special on lubrication, on the material structure, to run pneumatic or electric components on a dry room of -40 up to -60-degree dew point. And therefore we go two ways. On one side, we certified our products with the German Fraunhofer Institute to have a certificate of a clean room and a certificate of a dry room. And there is a big difference between clean room and dry room ready and clean room and dry room certified. And we also extraordinary introduced products, especially for battery manufacturing, like this fitting series. You see it's a composite material between stainless steel and POM. And the approach was to saving capex on one side for the factories. It means this fitting series is 3 times cheaper than a completely full stainless steel fitting. And on the other side, the quality approaches, it's going up to 20 bars. We all know no one wants to run a pneumatic application with 20 bars, but it shows up that the bearings and the sealings inside are much, much higher. A normal stainless steel fitting is going up to 16 bars or 12 bars. A plastic fitting is going up to 8 or 10 bars. Means if you use our Pneufit E-Series, you save capex on one side and you save OPEX on the other side, because the maintenance time is 2 times less.
Right, we are on the Electrofit stand, and we are looking at services allowing for the electrification of vehicles. What we're looking at here is a kind of integrated OEM motor and drivetrain. So electric motor, inverter, transmission, power in here 200 to 400 volts, control, park brake, that type of thing. Because these are OEM units, these are manufactured in high volume, and Electrofit has access to these, and then their role is to integrate these into other vehicles that would benefit from electrification. So for example, there's a whole bunch of the types of vehicles that these could be integrated into. We were talking just about industrial vehicles here, like forklift trucks, where they may be operating in an environment where an electric drivetrain is the safest and most convenient option. There's a whole bunch of other stuff, logistics vehicles, agricultural, off-road, leisure mobility, that type of thing. And really the benefit is access to the OEM units here due to their kind of price and availability because of the volume they're manufactured in, and then bespoking them to those environments. So process to drive electrification, which is reducing fossil fuel consumption, improving sustainability, and then you've got the reliability and durability of these units adding to that as well. So that's Electrofit. Right, we are here on the Innovate UK stand, and we are looking at FluoRok, which is a novel process for turning what was a linear process, shall we say, into a circular process for a material referenced as LiPF6, which is integral to the manufacture and operation of lithium-ion batteries. I'm here with Andrew, who is the guru and font of all knowledge on this technology, and I'm going to hand over to Andrew now to just talk us through the importance of this and what it means to the battery manufacturing process. Over to you.
Yeah, hi. So Andrew Schwartz, VP of Business Development at FluoRok. So FluoRok introduces a new platform technology for fluorochemicals. So today, fluorochemicals are all produced with a highly toxic, non-sustainable, high energy and high cost process. First you take the mineral, this is calcium fluoride, and it's in the existing process it's digested in sulfuric acid to make a highly hazardous, challenging intermediate called hydrofluoric acid. If you had a centimeter on your skin of hydrofluoric acid, you'd be dead within 24 hours. This product is made of around 1.5 million tons per annum, so very large scale, very, very dangerous, hazardous chemical engineering technology. 80+% of that product is made in China as well, so a very challenging supply chain risk for Western companies. That hydrofluoric acid is then used to produce all fluorochemicals, of which one of them is the product that we're targeting, LiPF6 or lithium hexafluorophosphate. The other 40% goes to processing. So this is used to do metal etching, metal cleaning, semiconductor manufacturing, and actually in aluminium manufacturing to make aluminium metal. FluoRok reinvents this whole supply chain for fluorochemicals. FluoRok can take the waste streams that come out of that etching process, remanufacture them into a novel intermediate by taking our mineral waste source of calcium fluoride, reacting it with a potassium phosphate, which is a food additive which exists in many different areas. Things like Coca-Cola uses this product to make a novel intermediate. That novel intermediate that we call the FluoRok reagents can then be used to make almost any downstream fluorochemical. So ranging from intermediates that would go into agricultural and pharmaceutical chemicals through to what we're talking about today, which is LiPF6 or lithium hexafluorophosphate, which is one of the crucial supply chain ingredients for lithium-ion batteries. This is the salt that enables the lithium to shuttle back and forwards between the anode and the cathode, or the electrodes, as you're charging and discharging the battery. It's about 15% in the electrolyte, and there's about, and it represents up to 5% of the overall cost of the lithium-ion cell. So kind of really significant stuff. FluoRok's technology reinvents that manufacturing of that product for the first time, enabling local manufacturing with lower capital, increased sustainability, and as mentioned, utilizing the circular economy for the first time for fluorochemicals.
Brilliant, excellent, thank you very much. Can you maybe just finish by explaining where you are along the sort of development and commercialization phase? What stage are you at with this technology?
So the material's been proved in the pilot scale, and actually we're here in the Innovate UK stand because we've been lucky enough to be supported by a number of grants from the Automotive Transformation Fund and actually the Faraday Battery Challenge, who have now rebranded to some name I can't quite remember, to develop a pilot scale manufacturing. So that means we can develop up to 10 kilograms of this product.
Okay.
The next stage, we're developing the demonstrator manufacturing. This will be replicating all of the industrial technology for full-scale manufacturing.
Okay.
We expect that to come on stream, and it's currently being planned and developed in the north of England. Okay. So we'll have up to 100 tons of manufacturing by the end of next year.
Brilliant. Well, we'll capture your details and we'll keep an eye on what you're doing, and we'll follow your journey. Thank you very much.
Thank you very much.
We are here on the Turntide stand, and we're going to be looking at motor design and manufacture, inverters and batteries, controls, etc. bespoke applications, looking at the type of applications up there, off-road e-mobility, that type of thing. But also, we're going to be talking about a deal that's just been done or announced with Hitachi for the development and application of this technology into hybrid trains. So we're going to talk to Matrisvan, who's going to talk us through all of this technology. So over to you.
Hi, very nice to meet you guys. So Turntide's been at the forefront of various technological innovations. We've been developing power electronics, motors, and battery systems for many years now. And each of those products have key USPs with them. So the motors are highly torque dense and power dense. So if you've got fairly space constrained applications, then they are a good fit for that end market. And the demands from the electrification world are only going in that direction. They want more power, more torque, more energy in fairly space constrained environments. But something that also offers a lot of customizability to the end OEMs. In order to make the OEMs more competitive to the customer, they are expecting a lot of custom features as well. So we've got that capability where we have standard off-the-shelf products, but also easy customizations around those products to make it appealable to a wide variety of OEMs.
Yeah, brilliant. Okay, just walk us through some of the products you've got here.
Yeah, so this is our new range of axial flux motors. They're ideal for high torque, high power density, space constrained applications. And they come with a lot of configurability as well. So you can have configuration in terms of the size, weight, the torque and power delivery capabilities, as well as the interfaces. So they come with multiple interfaces in terms of the shaft and spline arrangements that can integrate with multiple transmission types and powertrains as well. Applications across automotive, commercial, so trucks and buses, as well as hybrid and marine propulsion. Okay. So the design of this makes it highly versatile, and the magnetic topology inside it is giving it that extra performance edge as well. So you can get a lot, almost 2 to 4 times more performance compared to radial flux motors in the same space package, and at a similar cost point as well.
Now, I may make myself look a fool here. I'm assuming power in, control, cooling?
Cooling, yes.
Okay.
So this is a 3-phase output.
Yep.
That basically the inverter phase wires will be coming in.
Yep.
Controlling the motor. Okay. Cooling inputs, low voltage control.
Yes.
Yeah.
Okay. And can these be parallel?
Yes. So these are modular and stackable. You can have multiple ones of these stacked together to give you that scalability in terms of power and torque throughput as well.
Okay. Maintenance free, I guess?
Yes, they are designed to be maintenance free.
Yep.
And long life as well. So a lot of simulation and design work has gone in to ensure that they can have a long lifetime, which is what the OEMs want. They're asking for 10, 20 years of design lifetimes and operational lifetimes as well. Yep. So this has been designed with that in mind.
Okay. Yeah, I'm talking to semiconductor companies at the moment involved in the sort of inverter area. And it's interesting because they're looking at product durability and longevity, keeping those semiconductors available for maybe 20 years, so you don't have to do product redesign.
Exactly, and thinking of the end customer demand as well. If you're having an electric vehicle or equipment where electrification has been used, you want it durable for a 10, 20-year lifetime as a minimum. For the total cost of ownership benefits to actually fructify, and all of those design considerations are going into our product design as well. Yeah. To make it last for that long.
Yeah, this is a battery pack?
These are modular battery packs, yes. So they've been designed to be highly safe. There's lots of regulations and there's safety concerns around batteries as well. So these have gone through rigorous testing procedures to make sure that they comply to all the EU and UN regulations around safety. They come with a battery management system as well to make it more efficient, usable across the board. Yes. The beauty with these is this is a standard modular pack, but we can have custom designs. So the Hitachi development, they've won a contract in terms of designing a custom battery pack for the solution, has been an extended version of this for a high voltage system. Okay. So that's a 2,400 volt system, which will be powering the first battery powered trains in the UK.
Right, amazing. And this particular pack here, what type of application would a unit like this be?
So this has been designed to be highly energy dense, so for compact off-highway construction equipment and machinery. Okay. So that's an industry that's been calling out for electrifications for a long time, and giving this modular highly energy dense, compact solution, which is also safe for use, is the perfect recipe for success in that industry.
Just tell us about this Hitachi project. We've been looking, we've been various rail exhibitions over the years, and we've been looking at hybrid train design. Where is that at now in terms of commercialization, application? What's driving it, and where's it going to first appear?
So we've been involved for many years in the first generation of development for battery-powered trains. We did the first generation development that's been actually tested on the tracks, and it's been successful. So it's undergone a wide variety of testing in Japan, in the UK as well, on the tracks. And once it's been considered commercially and technically viable, now it's moving into the commercialization phase, where we'll have the next generation of the design, which is fit for mass commercialization rolled out in the next 18 to 24 months.
Okay. And it's for areas of the network where they have difficulty getting in sort of rail-side power or overhead cables. Yeah.
So there's a great amount of infrastructural spend that governments will have to do in terms of electrifying the entire rail network. So this is a good solution if you still want to electrify and get the decarbonization benefits without having to have a large amount of infrastructural spend. Battery-powered trains are the solution that fits that demand.
And just one last sort of closing question. In terms of sort of inverter and battery control, you're also handling the software and firmware design of that?
Yeah, so we have capability for battery management system, software and firmware design in-house, and we are developing all of that in the UK.
We've been lucky enough to be awarded the contract to build Hitachi's next generation of battery passenger rail. We'll go into a tri-mode train, so it can run on diesel, our battery system, and overhead power lines as well.
Is that going to be a first? I mean, a tri-mode train? Will that be the first application of those three technologies in a single vehicle?
It'll be the second generation. So Turntide developed the first generation over the past 3 years, and that trial's been successful. And we're now moving on to the second generation of that design.
Right.
So.
We are now on the University of Surrey stand, and I am with Robert, and we are talking about material aging. And the reason that that's important to us and to our readers is that the durability of a product, which is obviously intrinsically linked to the capabilities of the materials it's manufactured from, is a real contributor to a sustainable future. The longer a product is in service, the longer the planet has to reabsorb the carbon that was emitted during the manufacture of that material and product, and the less energy that has to go into manufacturing a new one and recycling that one. So understanding how materials perform over an extended period is absolutely essential to that, because you need to be able to measure and predict that with some level of confidence. So I'm going to hand over to Robert, who's going to tell us exactly what the guys do there, the type of equipment they've got, the processes they put these materials through, the simulations and predictions, and how that then manifests as benefits in the manufacturing industry. So, Robert, over to you.
Thank you very much. So here at the University of Surrey, the Centre for Engineering Materials, one of the areas that we're particularly interested in is how materials age and how they respond under extreme environments. So if you think about any material, and typically when you think about a university, you make something that's really fantastic on day one. But actually for real life applications, day one performance doesn't matter that so much. What you want is that your product is still going to be working years into the future. So what we're trying to do is understand how different materials respond under different conditions, and can we predict how much life is left in a material or a material system. So we're looking at all types of different materials. So it'd be a polymeric material, metallic material, composite material, or even a ceramic material. How do these systems and these materials survive over extended periods of time? So a really nice example is something like a wind turbine. So when you've got your composite wind blades out there or offshore generating power for us, how do those materials change their properties and how much life is left within that product? The first generation of wind turbines that were put out there are about 25 years old. They're nearing the end of their design life. But actually, if we can understand how those materials are aging and understand whether there is another 10 years worth of life in them, we can then take preemptive action and ensure that those products can continue serviceable life instead of having to be taken off and new products being made all of the time. So one of the cool things that we actually use to do this is an accelerated aging type system. So this little product down here is our showcase example, but we're back at home, back at our base, we've got big versions of this. And these chambers allow us to change the environmental conditions. So we can change the relative humidity within that system, we can change the temperature, we can fluctuate those. So we can increase the temperature, decrease the temperature, and basically simulate the types of conditions that our materials will be exhibiting out there in real life. So if we can do that, we can then understand how our materials change over time, and we can then start using model predictions to then look into the future and decide how well of our materials are going to survive going off into the future. So this is a really fun and cool, exciting area. We're working with AWE, and we've got a Center of Excellence for Materials Aging this area, which is open to all companies to join us. And we're creating a hub of excellence that build around that understanding of how materials age to allow us as society, us as engineers, to predict how all different types of engineered systems, all different types of material systems will survive into the future in order to deliver a sustainable future for all of us.
In terms of the modelling, is artificial intelligence involved in that process yet? If not, will it be? If so, when, and what do you imagine, how do you imagine it might help?
So artificial intelligence is absolutely a big part of this activity. One of the challenges with understanding the aging of the materials is there is just so much data. There's so many different ways in which you can change the environmental conditions, so many different permutations and combinations of those different changes. It's actually really difficult to address that in a systematic manner that allows you to do it in a very timely way. We could eventually do it if we did lots and lots of different testing, which is going to cost a huge amount of money and a huge amount of manpower. What artificial intelligence allows us to do is to interrogate that data and see the connections between different tests and see how different service conditions interact with each other. And that is absolutely essential, because if you think about how a system operates in real life, it's not just being exposed to a temperature change. It's being exposed to different temperature changes with different solar radiation, with different wind loadings in a continuously changing manner. And artificial intelligence is one of those key technologies that is going to help us as humanity understand what's going on. And at the University of Surrey, we are very active in developing that sort of artificial intelligence and that understanding to help us predict materials aging.
So we are on the Metis stand now, and I am talking to Joe about a battery safety sensor, effectively, called CellGuard. And I don't know if you can see the brochure here, but in addition to the sort of cell detection technology that would be in a battery per se, what we're looking at here is a completely different level of technology and it would say fidelity. So this particular sensor, which Joe's going to introduce to us, is measuring moisture content, shock load, gas, pressure and hydrogen. And I'm going to hand over to Joe now so that he can explain to us why all of those measurements are important and the benefits that brings to the life and safety and durability and reliability of battery systems in the future. So over to you, Joe.
Thanks. Yeah, so my background is basically, I started off in battery management systems, and obviously from that, observations of the battery management system. So typically at the moment, they work in looking at cell voltages and cell temperatures. The problem with using cell voltages, if you've got a lot of cells in parallel, you might find it hard to see an issue with a particular cell because it'll be masked by the others. The other one is through temperature of cells, but typically BMSs don't offer full coverage of all the cells in the pack, which kind of leaves you open a little bit to thermal events in the pack not being detected straight away by the battery management system, which is where CellGuard comes in, basically. So we tried to look at some of the weaknesses in current battery management systems and we designed the sensor to try and help alleviate some of those. So as you mentioned, it looks for moisture ingress inside of the pack, but it also looks at other things like dew point. So if you're actively cooling the pack, you might want to know dew point, so the temperature which you can cool the electronics down to. It's got shock measurement, so the point of that is to try and detect whether you've overg'd the pack to reduce write-off of battery packs. It has gas detection. The gas detection's there to look for the cell venting stage, but also the hydrogen sensor looks for the latter stage of a thermal event where hydrogen is formed. In addition, it can also look for moisture ingress from electrolysis, so hydrogen formed from that. The other thing it's got is a pressure sensor, so if you've got off-gassing in the pack, you can see perhaps along with the other sensors help produce false positives from a pressure increase. Yes. And it also measures air temperature, so all those things. It also has a CAN interface, so hopefully it should be easy for people to integrate. You can change CAN ID, CAN speed, things like that. It's also got low power mode, so you can sleep the CAN, it will monitor all the features and wake up if it sees one above a certain threshold. And one more thing, it's got a low side drive pin, so you can turn something on and off at a particular threshold. So all those things, yeah.
Brilliant. Let me ask a couple of questions. Is it an OEM designed-in product, or is it an aftermarket product?
So obviously we'd love to get involved with the OEMs. They typically are a tough nut to crack. We have been in conversations with some big OEMs. When we designed it, we actually had an original module which was an R&D one, which is low volume, and one of our customers asked us if we could productionize a cheaper variant, which is what CellGuard is. So what we've seen, usually the development cycle in terms of integrating a product like this for the big OEMs can be 1, 2, 3 years. The smaller guys seem to be faster to pick up on this. So we've got about 450 companies we've given samples to. About 150 of those have come back and bought more. Some of those are in a more advanced stage of integration and larger volumes, so up to 1,000 per year. The OEM conversations tend to be a lot longer-winded and take a lot longer. But yeah, hopefully we get involved with those guys as well. Yeah.
And of those ones that you're working with in that sort of bespoke area, smaller volume, what are the sort of applications you're looking at?
It's really wide, varied. I'd say the large ones are buses, public transport. They've gone into boats, aircraft, static energy storage, test and measurement. So if people are cell cycling, they might want to leave that going, but know if there's an issue with the pack. So wherever there's energy storage, basically, for batteries. So it's originally for vehicles. What we do is we offer the part in a part number, and you don't have to have all the features I just spoke about. You can just call off the features you want on the part number. So, reduce your cost that way.
One final technical question, just for my own personal knowledge. The moisture sensor, is the moisture, is it generated internally by the processes of the battery, or is it something that's leaking into the battery through maybe a broken seal, or is it a bit of both?
Yeah, so most battery packs have a breather port on the pack. So if you've got a breather port on the pack, you're breathing to atmosphere. So that means the moisture that's in the atmosphere can get inside the pack. But as the pack's usually warmer or whatever than ambient, it will remain dry. So yes, you would see it. You wouldn't typically see it inside a pack from formation from the cells. They wouldn't form water. Another way it might happen though would be from active cooling. So if you've got active cooling inside the pack, you might have a leak of the coolant into the pack. So that might be another way you might see moisture in the pack. Yeah. So either from atmosphere through the breather port, or from a potential leak of coolant inside the pack.
Yeah, gotcha. Yeah. Okay, thank you very much.
No worries.
Very interesting insight.